transfer the slides properly. Dan Hawk, the Think Indian. So, you know, I had mentioned to Dr. Greenhouse here earlier, when some of the material that I received, for the nuclear material, was part of growing radishes on the moon for the College of Menominee Nation. Okay, so that's how this all started. This started back in 2007 and launching rockets and getting material that apparently then ended up being radioactive, right? So, and I was using this material to grow radishes. And I was wondering why. The radishes would grow really fast and they would burn out. But it come to find out, and I was thinking it had to do with iron and the electrical properties of the iron. But it was thorium. So, and I wanted to go back to the MOSA standard, right? Because I talked about this morning, but I didn't have this slide. So if you'll notice in this slide that there are the three things that are necessary for the Lunar CubeSat standard, right? So it is a connecting, to being able to connect it to something like a rover, and then something to be able to use as a cable, right? So in this case, it is the Honeybee 11-pin, and it's a dust-tolerant connector. And so this is what it would look like, right? So you need a connector, you need a physical adapter, and then you also need the power and the communications, which is a part of this. So the idea is to put a CubeSat onto a rover, being able to plug it in, and it's good to go. You're able to do lunar surface science using CubeSat standard, right? That's what that's it about. So Lunar MOSA CubeSat standards have benefits to improve competition, keep technology fresh, incorporate innovation, enable cost savings because of the standard is, we all know that the CubeSats are extremely cheap compared to the larger satellites, and improve interoperability, the ability for them to talk, communicate with each other, and being able to use this very similar modules like power, communications, electrical power systems, and those kinds of things. To establish an enabling environment, to employ modular design, which is about the MOSA issue, is about everything's being modular. Design key interfaces, which we're talking about, which is the plugs. Use open standards, and to certify the conformance of those. So currently, when you're talking about CubeSats, generally today, they would go to Cal Poly in San Luis Obispo. They would go do a shake and bake, they would test it, and they would say, okay, you're good to go, you're ready to fly, then you're integrated onto a rocket, and up you go, and then you're deployed. So we need to do the same thing with the lunar surface standard of a CubeSat. It has to be to this very similar standards, except for the lunar surface versus that of orbital space. Here's our mission to the International Space Station. Here you see what they call a MISSI rack, and the MISSI rack is it has to do with it's the Materials International Space Station Experiments rack, and we have two missions on that particular rack. So the first time that you're going to see Native Americans going into space specifically to do missions on the International Space Station. Here, in this particular slide, is that Indigenous people are different in a certain kind of way than most others, because we have this federal tribal trust responsibility, something that Michelle was alluding to. The federal tribal trust responsibility between the federal government and Native American people goes way back, right? So we're talking about manifest destiny kind of thing, and the change from, into the issue of assimilation. But here is a NASA test chamber that now belongs to us. It is a 3x5 space engine test chamber. It's at Marshall Space Flight Center, and we are able to use this and get this piece of equipment and to put it somewhere and to be able to create our own space facility, to be able to do our own design, our own capability. ITEK, interconnectedness. I talked about this morning of how How is it that we come to be to understand, how we do things in space, right? So the ITEK interconnectedness scientific method is different. On April 12th, when I was at NASA headquarters, along with Michelle, right, we were brought in for the Artemis ethics workshop, and I introduced this idea, right, the interconnectedness, the scientific method. What happens is that our Western understanding of the scientific method does not really work, right? So from an indigenous perspective, what's missing? What's missing is that when you're done with your research, what happens is that you're done with your research, right? But in an indigenous way, when you're done with your research, what you should be saying and what you should be doing is you should be saying, how is my research connected to all other things? How is my research connected to the rest of the world? And so if we were to ask those questions when we go into our science classes and we say, okay, we're done with our research, now what is the results? How does that result reflect, how does that results incorporate into all other things, into other mechanisms, other research? And if we were to ask that question of how it's interconnected with other things, we would be a much better world today. And you can imagine, regarding pollution and pesticides and, ozone and, different types of, pollution, and even with pharmaceuticals and, problems with, taking medicines that's not good for you, things like forever chemicals. If we were to ask the question, how does it interconnect with other things, we would be able to maybe stop and think and talk about, this precautionary principle before we go forward in doing things. Had that happened, we would be in a better place today. One of the other things I want to talk about, ITEK, Indigenous Traditional Ecological Knowledge. We are not treated the same as the Western scientists. And our understanding of how we do things when it comes to science and engineering may not be the same as Western science, but we're left out in many ways. So you ask the question, if you're a tribal government, and we have 576 tribal governments, how many of those tribal governments have patents? How many of those tribal governments own patents for things that are indigenous? And I would probably guess that none of them have patents on the indigenous properties that they have, the indigenous knowledge that they have. There is no patents. And that's wrong, because what's happening is that the Western science is taking our indigenous knowledge and creating patents on it, and then basically forbidding us to use our own indigenous knowledge to our own benefit. So we need to create journals. So I've created an indigenous, the ITEK journal, .wordpress.com, to create an indigenous scientific journal. And here, I showed this morning, the 2020 experiment, and I showed this to Nemrod earlier. My first prototype of a nanonuclear generator right here. And then here's another one, but this is a different prototype than the one before. And you can see this one is that little button is putting out 0.4 volts. One of the things that we're talking about when we talk about our rover when it goes on the lunar surface is we're going to be using artificial intelligence. And I don't think we've talked about that today, artificial intelligence. And so when we come about the issue of artificial intelligence, from an indigenous perspective, we look at how things are interconnected in the artificial intelligence. So it's one thing to have artificial intelligence, machine learning, taking statistics and then combining that with machine learning so it understands and learns, so it's able to do the tasks more efficient over and over, and becomes to be more and more efficient. But the efficiency needs to be tied to something. The efficiency needs to be tied to how it's interconnected with other things, right? Yeah, and tribal data sovereignty. tribal data sovereignty is one of those things that, we talk about Earth observation as Indigenous people, to be able to monitor our resources, to be able to monitor our climate change, our habitats. So there's two things. We go into space in a physical asset. We have a satellite. We put a satellite up. It's a tribal satellite. It's tribal sovereignty. It's tribal space sovereignty is what it is. We're in space, physical asset. That is a physical part of sovereignty because that satellite goes around the Earth 15 times in a day. That's tribal sovereignty. That's space sovereignty. But there's one other part to that. The other part of that is data sovereignty. Owning the data, being able to take the data on our ability to understand the resource, the habitat change, the climate change, and take that data as an Indigenous people, provide it to tribal leaders and say, tribal leaders, here is our data. What does it mean? How do we go about cultural preservation in the face of climate change? Here's the data that is our data, that we make our own decision firsthand. We're not given that data secondhand. It is our data. Tribal data sovereignty is extremely important because it's a part of what we would consider to be tribal space sovereignty. Tribal space sovereignty and tribal data sovereignty go together. They are hand in hand. And so climate change is one issue, right? So we know that in our northern population, our relatives in the northern populations, and also in the southern hemisphere, that are extreme. They're the ones that face climate change more rapidly and more disproportionately than the rest of the world. So when I consider climate change, and we talk about Earth observation as an Indigenous idea regarding tribal satellites, tribal sovereignty in space, we also talk about what does that mean. So that part of that is national security, because Indigenous people, as Michelle was talking about, we have land, we have capability, we have land ethic, that we have we have technology, we have facilities, we have population and people to work, and we have borders in national security, we have bridges, we have dams, we have ports. All of these things are regarding national security, and as a federal tribal trust relationship between Native American people and the United States government, NASA, our space Indigenous, like for example, Space Force, Space Command. We are all part of the national security, and it makes sense for tribal governments to be a part of the national security landscape, right? So part of that. Again, we are here, United Nations Science Summit, General Assembly 78, and one of the most important things, right? So, Sustainable Development Goal 8.7. Representing here is murdered missing Indigenous women. Most people don't understand or they don't know about what's happening, but there's a lot of Native American women and girls that have been missing. And part of having our Earth observation, having our own satellite constellation as an example, what it equates to maybe not necessarily a physical asset in space, but we're talking about spatial awareness, spatial intelligence, Indigenous spatial intelligence to be able to support trafficking, human trafficking, drugs, again, back to our borders, being national security. These are things that we're left out of. These are things that we're not a part of, but we need to be. So here today, United Nations Science Summit, General Assembly 78, we raised the idea murder missing Indigenous women to Sustainable Development Goal 8.7 for monitoring slavery and trafficking from space. Bullet holes. Here is a monument that was somebody decided to shoot, put bullet holes in our monuments. Again, when we come to monitoring our resources, our lands, our sacred places, it's necessary to have tribal space sovereignty. It's not a want, it's an absolute need. The identity of things in space. You know, as Robin alluded to earlier, that we have technology to be able to identify things that are less than 10 centimeters on a cube in space. We know that we have space debris that we can see that's basically baseball size, softball size. Anything less than that, we have a difficult time seeing. We are not able to characterize that debris. But if you have something in space that has the ability to characterize debris less than 10 centimeters on a cube, that's a value to us, because there's millions of pieces of debris that are less than 10 centimeters on a cube. So identity of things in space is extremely important. It's something that we were able to do. Back to the due regard again. Now, I talked about that earlier, but I told you what the equation was, but I didn't show you what it looked like because I didn't have the slide. That's what due regard, objective due regard looks like. Because up until this time, up until 2015, it was subjective. What is due regard? It was squishy, like a sponge. You didn't know what subjective due regard was, because there was nothing to equate it to. But the tribunal was able to do it. The tribunal was able to do it by saying, look, due regard in the second state, which is the one that's being impaired, is equal to the inherent rights minus the extent of the impairment, minus the value of the activity of the first state, minus alternative approaches. So really what that means is that if you take away the inherent rights, because everybody has inherent rights, you take away the alternative approaches, because if you had a new alternative approach, you wouldn't need it. So you have extent of impairment minus the value of the activity. And this gets back to why the SpaceX launch on April 20th did not violate due regard, because the extent of the impairment, which was huge, is equal to the value of the activity, which is also huge, and they basically are zero. Now, had SpaceX's activity not been very, very, very valuable, had they not had contracts with NASA, had they not have the ability to go to the moon and to land people on Artemis, that value of the activity would have been low and they would have breached due regard. But that's not the case. Their value of the activity is high. So you have to argue. If you can actually take numbers and you can calculate it out and say, no, they didn't breach due regard.